Do you want to rejuvenate your cells? Do you want to remove cellular waste? Do you want to keep your body in optimal condition? The answer is simple. First, check your health status, medical conditions, and medications. If there are no issues, time-restricted eating like 16 to 8 can be considered as an option. Why might it work? This slide explains everything. When fasting begins, autophagy may be activated in your cells. Autophagy, cellular self-eating. The 2016 Nobel Prize proved its importance. Autophagy breaks down damaged mitochondria. It removes abnormal proteins. Your cellular waste disposal system goes into full operation. What's the long-term result? Improved metabolism, enhanced insulin sensitivity. Cellular-level rejuvenation may occur. This is a fact revealed by cell biology research over the past decade. Autophagy itself is an established mechanism. However, research continues on fasting duration, which tissues respond and how much, and the relationship with long-term outcomes. And this is achievable. Last meal at 8 p.m. Fast until noon the next day. With this, your cells begin to transform. It's not just about fasting duration. The effect varies with meal quality, total intake, and eating time. If you're on diabetes medication, there's a risk of hypoglycemia, so don't start fasting on your own. Always consult your physician. Today, let me show you the scientific evidence. Autophagy was proposed in the 1960s by Christian de Duve. In the context of lysosome research, he presented this concept of autophagy, meaning self-eating. But the detailed mechanism was elucidated in 2016 through Yoshinori Osumi's research. He uncovered the key genes and mechanisms of autophagy through genetic analysis using yeast, winning the Nobel Prize in Physiology or Medicine. What's happening inside your cells? During starvation, low nutrition, or exercise, cells experience stress. This stress acts as a trigger, forming a small membrane structure called an autophagosome. This autophagosome engulfs damaged mitochondria, abnormal proteins, and pathogens. Next, it fuses with a lysosome. The lysosome, your cell's digestive organ. Here, the engulfed material is broken down. The broken down amino acids are recycled. It's the cell's survival strategy. So how does fasting activate autophagy? In animals, marker changes have been reported in a range from several hours to about a day, depending on organs and conditions. However, mice have a metabolic rate approximately 7 times higher than humans. Because humans have different metabolism, there's a theory that longer duration is needed. The precise timing is still under investigation. Here's the mechanism. During fasting, insulin levels drop. This suppresses nutrient signaling, primarily mTORC1. mTORC1, the command center of cell growth. When this is suppressed, cells switch from growth mode to survival mode. At the same time, AMPK, the energy sensor, becomes activated. When energy is depleted, AMPK promotes autophagy. These pathways trigger autophagy. Here's an important point. Response time varies by tissue. Brain, liver, muscle, each activates autophagy at different timings. Individual variation is also significant. The most dramatic change in fasting is the metabolic switch. As fasting progresses, the glycogen stored in your liver significantly decreases and begins to run out. Glycogen, the storage form of carbohydrates. Depending on conditions, around 12 to 24 hours, your body starts burning fat. However, depletion timing varies greatly among individuals and conditions. Fatty acids are released from fat cells. These fatty acids are transported to the liver and converted to acetyl-CoA through a process called beta-oxidation. Ketone bodies are synthesized from acetyl-CoA, primarily beta-hydroxybutyrate. These ketone bodies become the energy source for the brain, heart, and muscles. The brain typically uses mainly glucose. However, when ketone bodies increase during fasting, ketone body utilization increases significantly. Ketone bodies are extremely efficient as brain energy. Metabolism switches from carbohydrate burning mode to fat burning mode. Fasting may improve insulin sensitivity. According to some studies, fasting insulin and HOMA-IR can improve. However, The effect size varies greatly depending on the subject and method and is not consistent. How does it work? During fasting, insulin secretion decreases. Your cells, insulin receptors, rest and recover their sensitivity. When insulin is constantly high, receptors become desensitized. This is insulin resistance. Fasting may reverse this resistance. However, effects independent of calorie restriction are limited. There's an even more remarkable change. Growth hormone secretion. Fasting significantly increases growth hormone secretion. Research reports increases reaching several-fold. What does growth hormone do? It promotes fat breakdown. It protects muscle. There's concern that muscle is lost during fasting, but growth hormone prevents this. However, this is about short-term fasting. Long-term extreme fasting causes muscle breakdown. According to multiple studies published in recent years in prestigious journals like Cell Metabolism, changes in inflammatory markers have been reported. Some studies show significant decreases in inflammatory markers like IL-6 and CRP. However, effects on inflammatory markers are inconsistent across studies. The magnitude of reduction varies greatly depending on subjects, obesity levels, and fasting duration. We cannot definitively say that fasting alone produces large decreases. These are all indicators of chronic inflammation. Chronic inflammation increases the risk of heart disease, diabetes, and cancer. Fasting may suppress this inflammation. Now let's return to the mTOR pathway discussion. mTOR promotes cell growth, but when constantly activated, aging accelerates. Moderate suppression of mTOR through fasting activates SIRT1, a longevity-related gene. Animal experiments show this extends lifespan. What about long-term effects in humans? Research is still ongoing. However, animal experiment results are extremely promising. Intermittent fasting has several protocols. The most common is 16 to 8. 16 hours fasting, 8 hours eating. This has the most research and established safety. It's suitable for beginners. Adherence is high. Next is 18 to 6. 18 hours fasting, 6 hours eating. With longer fasting time, hunger duration increases. However, it's not consistently superior to 16 to 8. Caloric intake and meal quality are crucial. As the eating window narrows, nutrient intake planning becomes more important. And OMAD, 1 meal a day. 1 meal per day? This is for advanced practitioners. Fasting time is about 23 hours. While hunger duration extends, metabolic markers don't necessarily improve. Attention to post-meal response and nutritional balance is required. The biggest risk is nutritional deficiency. Getting all daily required nutrients in one meal is extremely difficult. Protein, vitamins, minerals, cramming everything into one meal. Realistically, it's unsustainable for most people. Here's an important recent finding. Latest research shows that even with the same 16 hours of fasting, when you eat matters. ETRE, early time restricted eating, which avoids eating after sunset and completes meals in earlier hours, may produce greater health benefits. For example, research is increasing, showing that 8 o'clock to 1600 is more effective for insulin sensitivity and blood glucose improvement than 12 o'clock to 2000. Late-night eating may disrupt circadian rhythm and offset fasting benefits. Which should you choose? It depends on your lifestyle and goals. If weight loss is your goal, 16 to 8 is sufficient. If you seek deeper effects, try 18 to 6. And if possible, complete meals in earlier hours. I don't recommend OMAD unless there's a compelling reason. Fasting isn't a cure-all. Let's talk honestly about risks. For women, fasting may affect energy balance. In women, when weight loss and total energy deficit overlap, menstrual irregularity risk increases. This increases further when dietary restriction combines with exercise and weight loss. If women try fasting, a more cautious approach is needed. Start with 16 to 8 and carefully observe your body's response. If you fast, it's important to design it without falling into energy deficit. If there are changes in your menstrual cycle, stop immediately. Next, the risk of muscle breakdown. Long-term extreme fasting breaks down muscle, especially when protein intake is insufficient. I said growth hormone protects muscle, but that's a short-term story. With fasting beyond several days, muscle breakdown begins. Furthermore, certain people should avoid fasting. Diabetic patients, especially those using insulin. Those with a history of eating disorders. Pregnant and nursing women. For these people, fasting is dangerous. Always consult a physician. Let me tell you the final important point. Including 2024 conference presentations, debate continues about long-term effects. Just because you're fasting doesn't mean you can eat junk food. Meal quality is the top priority. Don't use fasting as permission for unhealthy eating. Now, let's organize today's key points. Here's today's summary. First, cellular level changes may occur through fasting. Autophagy may be activated, potentially removing damaged mitochondria and abnormal proteins. Metabolism switches from carbohydrate burning to fat burning, producing ketone bodies. However, individual and tissue variation is large, and research continues on precise timing and effects in humans. This isn't just a weight loss method. It's an approach that may work on the cellular recycling system. Second, fasting effects are shown in research, but results aren't consistent. Some studies show improvement in fasting insulin. Growth hormone increases significantly. Some studies report decreases in inflammatory markers. However, effect size varies greatly with subject and method. The impact of calorie restriction is also significant. Evidence exists, but it's not a cure-all. Third, understand risks and practice carefully. Women have menstrual irregularity risk. Long-term extreme fasting breaks down muscle. Meal quality and total intake are top priority. Those on diabetes medication should consult a physician. Listen to your body's voice. Will you start fasting today? Or will you first consult your physician and try it carefully? Share your thoughts in the comments. Thanks for watching until the end today. This channel explores the mechanisms of the human body and the science of health. With evidence, not emotion, with science, not trends, we illuminate your path to health. Subscribe to the channel, and let's learn the truth about the body together next time. Until next time.